what would you do? Add them up and divide by 6. Okay, so if we taken 10 tests, you would add them up and divide by 10. All right, so if I want the average of something that has an infinite number of values, you know, we can think of it as just adding them up, but how do you add up if there's an infinite value? Like temperature. You know, if I want the average temperature of the day, am I taking the temperature every hour and averaging those, or would that be the true average temperature? Probably not. So what if I did every minute? That would be better, but would it be the exact? No. So if every second we're getting closer here, the more we add up. This is like the limit as n goes to infinity of the sum of all these things, which is really the definition of an interval, isn't it? So if I want the average value, okay, we know that if we just integrated this, we would get the area contained. An average, you have to add them all up, so that's the integral piece. And then we have to divide by the number of items. So the question is, if I want this average for a function, we could add them all up, but then what are we going to divide by? And I put the slides on here for the long, complex definition, but if you guys are okay with it, I don't think I'm going to go into that. I think I'm just going to stick with this. So all we really have to do then, the integral gives you the area under the curve. To find the average, you have to divide by the length of the curve. So if it's starting at 1 and ending at 20, its length is 19. So I have to divide by 19 or multiply by 1 over 19. So when I'm asking you to find the average value, all you're going to have to do, integrate like normal, but you'll have to multiply by an extra fraction to get the average value. Okay, so it should be a fairly simple calculation. So let's try one. Let's find the average value of the function f of x equals 1 plus x squared on the interval -1 to 2. So if I want the average value, we're integrating from -1 to 2. My function, 1 plus x squared dx. So in front, I do 1 over the ending minus the beginning. This fraction is really your only new piece. That's what makes it an average value instead of just the area under my curve. So that gives me a 1/3. Antiderivative of 1 is x. Antiderivative of x squared would be 1/3 x cubed. And I'm evaluating that from -1 to 2. 2 to the 3rd is 8. So if we distribute, we get 3 plus 9/3. 9/3 is 3 plus 3 is 6. Times 1/3 is 2. So the average value is 2. Is that okay?
Yes, ma'am.
The second type of question that I might ask you in this, is there a number c where the function is exactly equal to the average value? So in other words, like for this example, does this function ever equal 2? Okay, so if we're thinking about this, that's kind of the mean value theorem. Remember we said way back when we did the mean value theorem, we had these conditions, you know, it had to be continuous and differentiable. And if it was, then we knew that somewhere, what was true? The derivative was equal to, it's been a long time, the slope of the function, because we know the derivative is just like your tangent line, so somewhere that was equal to the slope. So in other words, this is going to be true for our functions because of the mean value theorem, that when you find the average value, somewhere your function would equal the average value. Okay, that's just relating it to something we had done before. So I might ask you to find that number. So it's not too difficult. Find the number where the mean value theorem holds. We already know from example 1, we found that the average value was 2. So I'm asking, when does this equal 2? So you subtract over your 1, square root, plus and minus. We get positive and negative 1. You should verify, are both of those in my interval? Yes, so that's my answer. You could get multiple answers where one of them wasn't in the interval. So if I got plus and minus 2, I would only use 2 for my answer, not the negative 2, so it has to fall in our interval. So those are really the only 2 pieces that we have here. Let's do, I'm going to skip this one. I want to do this one. All right, can you guys find this average value for me? Okay. So you're integrating from where to where? Of our function. And what do we need to put in front of it? So we get 1/2 times the antiderivative of x squared is 1/3 x cubed. And 0 to 2. 2 cubed is 8, minus 0 cubed is 0, so 8 over 6, or 4/3. Is that okay? What if I said, find C such that f of the average value, so that's just another way of saying the average value is equal to f of C. What do we have to do there? Yeah, we just take the original function and set it equal to our average value, which was 4/3. So if I'm asking you to find that C, I'm just asking you, set your function equal to your average value. And then if we work that out, to get rid of a square, we know we have to square root plus and minus. Square root of 4 is 2. We don't know the square root of 3, so we get plus and minus 2 radical 3 over 3. Are both of those in my interval? Okay, so my final answer would just be the positive. So that's the point between 0 and 2 where the function equals the average value. Is this okay? Let's do, let's do one that's not so pretty. We have third trait function in every now and then. Can't let that go away. So in Athens, Georgia, the mean daily temperature in degrees Fahrenheit, T months after July 15th, is closely approximated by this function. Find the average temperature between September 15th and December 15th. Okay, T is the number of months since July 15th. So September 15th would be when T is September is how many months after July? 2. December would be when T is
4.
5.
Who said 4?
So we're going to integrate from 2 to 5. And what would I have to put in front? 1/3. Antiderivative of 61 is 61t. Alright, let's think about this. Antiderivative of cosine is sine. You know, when you have a trig function, the angle doesn't change. Okay, when we did this derivative, we'd have to do the chain rule. What's the derivative of pi t over 6? Or think of that as pi over 6t. So the derivative of that would be pi over 6. So we have to put the reciprocal in front, which is 6 over pi. So I have to do 18 times 6 over pi for 108 over pi in front of that. And I'd say we're probably going to need a calculator for this one. Make sure you're in radian mode, please. So we have to do 1/3 times. I got an average temperature of 56.8057. I just want the average value of g of x equals x to the negative 1/2 on 1 to 4. So when I set it up, I'm going to integrate from 1 to 4 of my function x to the negative 1/2 dx. And what goes in front?
1.
Negative 4 minus 1. You add 1 to the power, you get a positive 1/2, so that means you need a 2 in front. Okay, 4 to the 1/2 just means the square root of 4. So that's 2 minus 1 is 1, times 2/3 is 2. If I asked you to find c, so that the average value equaled f of c, what do you have to do? Set the original function equal to 2/3 inside. Okay, are we good with this stuff? So the quiz tomorrow is 6 questions. 2 questions are like this. So one of them will be find the average value of this. One of them will be find the c so that the average value is equal to your function. Okay, so there's 2 questions on your test. Or on the quiz, sorry, not test. Then there'll be 2 area problems and 2 volume problems. Do we want to kind of review a little bit? Okay. I don't want to make up these problems because they don't work out pretty. So let's try some. If I said,
I thought that said 1 through 90. I was like, dang, I'm gonna be on this for a minute.
I want you to really get plenty of practice in.
Huh? Dude, this is like not.
Here we go. If I asked you to find the area between these, I would expect you to draw a picture. Now your picture, like, I'm not going to be counting off if your points aren't exact, but I want you to draw enough that I know you're kind of thinking about this, because we have to know which one goes on top and which one goes on the bottom. Remember, area between 2 curves, it's basically top minus bottom or right minus left, depending if you're doing it in terms of x or y. We need to know where they meet, and that's pretty easy on this if you just set those equal to each other. So I could bring everything to one side. I could take out a 2x. Leave me with x minus. So I get x equals 0 and 3. So those are where the graphs intersect. So really I just need to draw my graph between 0 and 3. You know, if I put in 0, 0 squared is 0. If I put in 3, 3 squared is 9. Okay, you can always do more points. 1 squared is 1. 2 squared is 4. It's just kind of depending on how much you want. So there's that one. This one, if I put in 0, we get 0. If I put in 1, I get 6 minus 1, which is 5. If I put in 2, I get 12 minus 4, which is 8. Put in 3, we get 9. So we're just looking for that. So I'm going to integrate from where to where? 0 to 3. Those are x values, so that means there's a dx at the end. When you're just doing area, it's just top minus bottom. So which one's on top? Minus the bottom, which was my x squared. How will you know if you get that wrong? You'll get a negative at the end, so your final answer would be the positive. Okay, so if you flip it, you don't have to rework everything. You just have to recognize that at the end. You should make your answer positive. So that's 6x minus 2x squared. Okay, antiderivative of 6x, 3x squared, minus 2/3 x cubed. And if we plug that in, okay, 3 cubed is 27, divided by 3 is 9, times 2 is 18. And we get 9. Alright. So can we handle something like that? I could give you some curves that maybe met more than once. So let's say I gave you same directions, find the area between y equals x cubed and y equals x. So we have to find out first where these things meet, right? So we can get the graph. So x cubed equals x. Subtract over your x. What would you do now? So we get x to be 0, 1, and negative 1. So these have 3 intersection points. Y equals x. So if you plug in -1, you get out -1. Plug in 0, you get 0. Plug in 1, you get 1. That's just a line. Y equals x cubed. Okay, it's the same 3 points here, so we need to figure out what else is going on. If you put in a -1/2, you get -1/8. If you put in a +1/2, you get +1/8. So we are trying to find these 2 areas. So what would we have to do on this one? Set up 2 intervals. The first one would go from -1 to 0. Those are x values, so it's dx. Plus, the next one goes from 0 to 1, dx. Okay, the only thing that changed was your top and bottom curve. So on the first section, between -1 and 0, which one's on top? x cubed minus x. The next section, which one's on top? X, so we have to do x minus x cubed. Is everybody okay here? So at this point, we just have to integrate both of them. So this would be 1/4 x to the 4th minus 1/2 x squared, and negative 1 to 0. After the first part, if you plug in 0, you get 0. Plug in negative 1 to the 4th is positive, so 1/4 minus 1/2. Next section, if we plug in a 1, we get 1/2 minus 1/4. Plug in 0, we get 0. Distribute our negatives. 1/2 plus 1/2 is 1. Negative 1/4 plus negative 1/4 is negative 1/2. So 1 minus 1/2 is 1/2. So you might have to set up more than one integral. All right, so 2 problems like your homework tonight, 2 problems that are area, like these that we just worked, and then we have 2 volume problems. So let's take a look at a couple volume examples. Let's do y equals 2 minus 1/2 x, y equals 0, x equals 1, x equals 2. Okay, so I should probably say a little more. Find the volume of the solid obtained by rotating the region bounded by all these curves around the x-axis. I just didn't want to write all that. So, we have to start with a good picture here. When I say y equals 0, what is that? The horizontal line. And if y is 0, that is just the x-axis. So basically, when I say it's bounded by that, we're not going below that line with the original graph. So we're just dealing above it. X equals 1 is a vertical line at 1. X equals 2 is a vertical line at 2. So I already know we're in between 1 and 2. We're above the axis here. So let's plug in the 1 and the 2 to here and see what we get. So if we plug in a 1, 2 minus 1/2 is 1.5. If I plug in 2, you get 2 minus 1, which is 1. So I just have this little section of a line. And what am I doing with that? Now I want to rotate it around the x. So think of it, I always told you just like reflect it over the x to start with. So then we've got this little solid here. Okay, is this hollow in the middle or solid in the middle? Solid. So this is just our disk method. So where would I start and stop this? 1 and 2. Those are x values, so this should be a dx. Okay, so with volume, you had to integrate the area of a cross section. So when we were rotating these, we were always creating circles, right? Area of a circle is pi r squared. What's my radius here? Alright, so if you want, you could take out the pi. I would probably FOIL that, so you get 4. It'd be negative 1x plus negative 1x is negative 2x. squared. Do I need to finish it from here, or could you guys do that? I don't want to take up too much of your time. Can you finish integrating? Okay. So we just want to practice setting it. So you know now to do your antiderivative and plug in. And your answer will have a pi on it. I want to do maybe one where we rotate around the y-axis. And then I really will be done. So if we did, how about, I'm going to take y squared equals x, x equals 2y, and do that one about the y-axis. All right, so I gave you fewer conditions this time. I didn't give you the starting and stopping. So what would we need to do? Okay. So it'd be easiest to do it in terms of y, wouldn't it? So y squared equals 2y. You could take out a y. So we get y equals 0. So those are my y values. Okay. So y squared equals x. If you put in a 0 for your y, 0 squared is 0. If you put in a 2, 2 squared it was 4. So your x would be 4. Your y would be 2. You could do more points if you wanted. If you put in a 1 for your y, 1 squared is 1. So we're getting this for the x equals y squared piece. Okay, x equals 2y, so if you put in a 0 for your y, you get 0. If you put in a 2 for your y, you get 0. If you put in a 1 for your y, 1 times 2 is 2. So we are rotating that around the y-axis, I said. So start by just reflecting it. I can't draw a straight line apparently. So then we are just rotating that. So what would we have to recognize on this one? What's true about the middle? It's hollow. So we have to think of it like the washer method when we set this up. So where am I going to start and stop? 0 and 2. Those are y values, so this would be a dy. Everything has to be y then. So when we talk about in terms of y, we think like outside minus inside. So if you are starting at the center, which one's on the outside? 2y. So area of that would be pi times 2y squared minus the inside one, pi times y squared. A lot of times I think on my examples I went ahead and just wrote the pi once out in front, so you can certainly do that. So 2y squared, so 2y times 2y is 4y squared minus y squared, or sorry, y squared squared, so that would be y to the 4th. And then could you finish it from here? Integrate and solve. So those volumes, it's really the setup that you need to remember. It's very similar to the area, but you have to do the cross section, so pi times the radius squared. Okay, so I want to give you the rest of the time. You know exactly what's going to be on your quiz tomorrow.